Hey, what's up guys? Back again with another video. In this video, I'm going to teach you how to build a simple linear regression model using Python. The goal of this video is to teach you the basics of how to build a machine learning model and hopefully get you interested in machine learning in general by letting you see how easy it is to get started. So if you've never done anything with machine learning before, this is actually a great video to start with. The only prerequisites that you need for this video is a knowledge of Python, just basic Python should be fine, and also mathematics. It's helpful to have an understanding of linear algebra, but it's not necessarily required for this video, as we're not going to go deep, into the mathematics of these machine learning models. So here's our data. It's just a simple table that has two columns, years of experience and then your salary. So this is something that you might see like an Excel spreadsheet or any other data format that contains tabular data. One of the most common ways to store data for data sets is CSV, comma separated values, but if we just take in display as a table, this is what we get. So with these two data points, like how many years of experience you have working and also your salary, you can probably imagine that there's some sort of correlation between these two things. So with that said, we can also visualize the data by simply plotting it on a graph. On the x-axis, you have the years of experience, and then on the y-axis, you have the salary. So now you can clearly see that as the years of experience grows, so does the salary. And it's pretty linear, as you can see. It's like almost a straight line. And you just heard me use the word linear, right? And this is where linear regression comes in. Linear regression is basically building a model that can estimate a linear relationship between one or more independent variables and a dependent variable. And if you remember from middle school, or whenever you took like pre-algebra or algebra, we learned about this formula here. Y is equal to mx plus b, which is the formula for a line. So m will be the slope of the line. X is going to be the independent variable, or in this case, the years of experience that someone has. B is going to be the y-intercept, or where it touches the y line. And finally, you have y, which is the dependent variable, or the value that we are calculating. In this case, that would be salary. It's called a dependent variable because it depends on the years of experience. Therefore, since we have a graph so we can visualize what this looks like, what the data looks like, it would be really nice if we could come up with a slope and y-intercept for this, this formula here that serves as a best fit line for this graph. We want to create a line that can best approximate the values that we have so that whenever we are given a new person with their years of experience, we can estimate their salary. So the better line that we come up with, the better estimations we can make on someone's salary based on their years of experience. Here's what that would look like. So we have our same graph as before, but now we have a line here that goes right through the middle. So that shows that we can come up with a line that serves as a best fit line for these data points here. And now that we have this line, we can come up with any years of experience, like let's say 5, we would just go up and then it would be right here. That might not be perfectly accurate, but it's pretty damn close because the line goes through all these points here. So the key point here is that the better line that we come up with, the better predictions that we get. So yeah, the values that we calculate for the equation itself is our machine learning model. And I don't know about you, but that is kind of crazy to me. When I first learned about that, I thought a machine learning model was some kind of crazy advanced thing, like a machine or something. I didn't know it was literally just like the slope and the y-intercept at a basic level. Now, of course, it's way more complicated when you get into the details of how those numbers are calculated and found, but thankfully there's some awesome Python libraries that makes it relatively easy for us. We can just sort of call functions and work with classes at a much more higher level than otherwise. We don't have to create all this ourselves. So let's talk a little bit more about the steps we need to take to make one of these linear regression models. So here's the basic formula again, y is equal to mx plus b. That's the formula that you should already be familiar with. But here's the formula rearranged in a more advanced way that you will see in machine learning. So if you've never seen this before, it may be a little daunting, a little scary, but it's not that different. You just have to know what these different symbols mean. So this first symbol here, the y with the little thing on top of it, is called y hat, and that's our predicted value. So whenever we come up with a model, it's going to give us a y, which will be our salary. And then you have these. So you have theta 0, theta 1, theta 2, all the way up to theta n. N is the number of features that you have in your data. Your features are simply your independent variables, the things that you're using to make your predictions. So in this case, the only independent variable that we have is the years of experience, but in much more complex data sets, you're going to have many columns. You could have like 20 columns that then predict someone's salary, for example, and that's when it gets crazy. We'll learn about that later, but luckily in this case, we only have one column, so we only have one feature. And then you have your dependent variable, which lines up with the predicted value that we have. So if n is the number of features that we have, and we only have one feature in this case, this means that our formula is only going to be this little thing here. So y hat is equal to theta 0 plus theta 1 times x1. Theta 0 is our bias term, or our y-intercept. They correspond with one another. And then for these ones here, where you have theta 1 and then x1 and then theta 2 and then x2, x1 is our feature value. In this case would be years of experience. So whenever you're using this formula here, you take the years of experience, so let's say 1.2, you plug it into x1, and then you have theta 1, which is basically our slope, which is also known as the feature weight. So just like up here where I said that we already have x and we already have y, and we just need to calculate the slope and the y-intercept, down here with the same formula just rearranged, we already have x, this is y predicted, but we already have y. So we just need to calculate the model parameters, which would be the weights. So theta 0 and then theta 1. And then if you have a data set with more features, like maybe their age, you would have more. So you would have theta 2, and then you have x2, which would represent the age. So to train this model, we need to split our data set into a training set and a test set. So that would involve taking this data set that we have here and chopping it up into two different sub data sets. The training set is the data that we give when training the model, that we actually use to train the model, and then the test set is used to evaluate the accuracy of the model after we train it. The reason that we have to do this is because if we test the model on the same data that it was trained on, then obviously we don't get a realistic picture of how the model can perform on data it has never seen before. The whole idea behind this is to give the model someone's years of experience and get their salary, which of course is unseen data. Like if you want to know what someone's salary is, potentially you would figure out their years of experience, you would throw that into this formula, and then it should give you a predicted value that is pretty close to their actual salary, if the model is good at least. The most common way to split the data is 80-20, so 80% of the data set will be for training and then 20% will be for testing. Those values can vary depending on different factors like how big your data set is or how small your data set is, but 80-20 is probably the most popular way to split your data. So once you train your model, once you evaluate it to determine that it's a good model, this is what you should obtain. You should have a slope, or in this case it would be theta 1, and then you should have a y-intercept, which in this case would be theta 0, which is the bias term as well. These two values here are the parameters for our machine learning model. Now that we have these, we can predict anyone's salary based on their years of experience. I want to make something very clear. The reason I'm posing it as M and B with the simple formula that we have above is because we're doing something called simple linear regression where we only have one feature. In most realistic examples when you're doing machine learning, you're going to have multiple linear regression where you have multiple features that you're going to be training a model off of. So that's going to be more helpful to know this formula instead, where you have many different features that all have different parameters. So theta 1, theta 2, and so on, all the way up to theta n, depending on how many features you have. And don't worry, in a future video, I'll show you guys how to do all of that. We'll deep dive into multiple linear regression, but for now, I'm going to show you guys the basics. So that's it for the introduction here. So hopefully you guys have an understanding of what the game plan is, what we need to do to create a simple machine learning model for linear regression. Now we're going to jump into the code so I can show you guys how to create one using Python. Alright, so we're going to build our very first machine learning model using Python. And the way we're going to do that is using something called Google Colab or Colaboratory. It's kind of like Google Drive where you can have, documents, but in this case, the documents are something called notebooks. And notebooks are a way to run Python code really easily, and it's really great for videos like this because I can share the notebooks with you and you can run them yourself without having to do any setup. You don't have to set up a Python environment, you don't have to really install any packages for the most part. It just makes it a lot easier. So I think I'll make another video in the future on how to do this a little more in depth, but for now just go to colab.research.google.com. I'll have a link for it in the description below. And we want to go ahead and create a new notebook, so we're going to do File, New Notebook in Drive. So this will automatically create the notebook in your Google Drive using your Google account. Let's start by giving it a name. We'll call it Simple Linear Regression. And the first thing that I want to do is add our data set. So let's go to Files. So here's where I found the dataset on Kaggle.com. Kaggle's a great website for finding datasets and other machine learning stuff. I'll have a link for this below so you can download it yourself and also work with it. But yeah, this website's going to be very useful in your machine learning future. You can get datasets, you can go to code, and you can see how other people made models using this data set. It's really cool to see other people's solutions. But yeah, we just want to download this data set, open that up. So we want to upload this file to our Google Colab. So we'll go back here, and I'm just going to go ahead and drag and drop it. There we go, it's uploaded now, so we should be able to work with it. We can even double click it to see what it looks like. That's really cool. So we can see our data set as a table. We can see that it has two columns, years of experience and salary, just as we saw before. First thing that you always want to do is import your data set. And there's a very basic package that almost everyone uses called pandas. So import pandas as PD. So we're importing the pandas Python package as the alias of PD. Another really popular package is NumPy, which is used for numerical processing, working with matrices and vectors and stuff like that, but we're not going to be using that for this episode. So to import this dataset, all we got to do is create a new variable dataset, and we can do PD for pandas, and we could do read_CSV, which stands for comma separated values. That's just the format of the data that we imported. And then now we just specify the path of where the file is located, so we could do salary_data.s or CSV. There we go. Now, once you have some code inside of one of these little cells here, you can go ahead and run it by clicking play. And look, it says it completed. It took 0 seconds, so it was really fast. No exceptions though, that's a great sign. So let's go ahead and print out our data set just to see what it looks like. So we can go ahead and do print dataset. Let's run it again. And here we go. Here's our data set as a nice little table here. So we have years of experience, we have salary, we have also the indexes of the various rows. You can also clearly see that as the years of experience grows, so does the salary. And it's a pretty linear relationship. So that's a great sign that we can build a linear regression model off of this. But now that we have this data set, what are some other ways we can take a look at our data to get an idea of what it looks like? Some other things that you can do is instead of just printing out the data set directly, you can print out the head of the data set. Because a lot of the time you're going to have a really big data set, like, thousands or hundreds of thousands of rows, right? So doing the head like that will give you just a sneak peek of what the data set looks like. So you can see the top 5 rows pretty much. That's just a quick and easy way to see what our data looks like. Another cool thing that you can do is describe the data set. So we can do dataset.describe. And now we can run this again. Now we also have some descriptions. We can see now that for both of these columns here, we have different, I don't know what you would call it, metrics. Now most of these are pretty self-explanatory. The one I really care about the most is the count. And all that means is that for every single row of this column here, how many values are there? So if there's a row that doesn't have a value, if it's null or something like that, that won't be counted. So this will be very useful in the future when we do data pre-processing, because we want to make sure that our data doesn't have any missing values to avoid issues. So since we have 30/30, this means that we pretty much have complete data. There's nothing missing, at least that we can see. We also have the average of the data, or the mean. We have the max, we have the min. Pretty cool. So that's just one way you could describe your data as well. And one more little thing you can do is print the shape of the data. So dataset.shape. So let's run this again. And here we go, we get 30,2. So even though behind the scenes Pandas is storing it basically like a little table, you can also think of it as a matrix. If you're familiar with matrices, you can also think of it as a multi-dimensional array. So this 30 here means that we have 30 rows, and then the 2 means that we have 2 columns. So you can kind of think of it as a 30×2 matrix or a 30×2 multi-dimensional array. Alright, so now we've successfully imported our data and we got to look at what it looks like. The next step, and this is kind of optional, you can also visualize your data as well. So you can take a look at what it looks like. So we can click code for a new code cell. You kind of want to split it up into different sections so that you can run them separately. To visualize our data, we're going to use a very popular library called matplotlib. So it's going to be matplotlib.py plot as plt, just like that. And then we're going to go ahead and plot the data. You don't really have to necessarily memorize all this code here. This is just something that you're going to be copying and pasting a lot of the time pretty much, or the more you write it, the more you'll start to remember it at least. We're going to make a simple scatter plot just to visualize what our data looks like. So on the X, we're going to have our years of experience. So we're grabbing those values from our data set, and then we're doing data set salary. So that will be for the Y. And then we can do X label, years of experience, and then plot Y label, salary. And then we're going to add a title if we want to. This is all optional, honestly, but we can do salary versus years of experience. There we go. And then finally, to display, we can do plot.show. All right, so let's go ahead and run it. Made a mistake there, fix that. All right, so now let's go ahead and run it. Boom. And here we go. So this is our plot, automatically generated by this matplotlib library that we imported. Really cool, right? That you can even do that within Python. It's so easy. And this is so helpful. Before we imported our data, we took a look at it. We can see that, as the years of experience grow, so is the salary. But I think visualizing it gives it a whole different perspective. You can really clearly see that if we can just make a line that goes right through the middle like that, we can have a pretty accurate model. Now that we've imported the data and we've also visualized it to see what it looks like, at this point you would do some more pre-processing to clean the data up and make it more useful for machine learning. But in this case, we have a very simple data set, and we also want to focus just on how to make a simple linear regression model. So we're not going to do that this time. I'm going to make a more detailed video on that in the future. So now what you usually want to do is take your data set, which is right now a pandas data frame, and split it up into a feature set and the target or the dependent variable. Now remember, again, the features are simply the columns that we're using to determine the salary or our dependent variable. So in this case, we only have one, which is our years of experience. So it's going to be capital X because usually you have more than one feature and you want to represent your features as a matrix or basically a multi-dimensional array. And then to extract our features from our data frame, we can do dataset.iloc, And then inside of here, we want to tell it what rows and what columns we want to extract. The syntax is a little weird, but let me write it out first. So first we're going to do colon, then we're going to do comma, space, colon, -1. So before the comma, that's where you specify what rows you're trying to target. In this case, in our data set, we want all rows, right? We just want every single row. So if you don't specify anything before and after the colon, then it'll just grab everything. And then after the comma, you have the columns that you want to grab. So if you don't specify anything before the colon, that's just going to be the first one, so the first column. And then after the colon, you want to tell it what the index is of the column that you want to stop at. If you do -1, that's automatically in Python going to target the last index. So it'll give you the index of the last column, so salary, but ranges are not inclusive for the last one. So that's not actually going to include that last one. So in other words, it's going to start at the beginning, so get all the columns except for the last one, all the way up until the last one, okay? It's a weird little syntax, but you get used to it the more you work with it. Alright, so now we have another data frame that just has the features, hopefully. So let's go ahead and print it out to verify that we actually have that. So we'll make another little code thing here. And we'll do print X. Make sure it's capital X, right? So make sure you run this one first. And then we're going to run this one. And there we go. So now we have a new data frame that we're printing out, except that has just years of experience only, but it has all the rows. So that's good. So now let's also extract our dependent variable, which is also known as our target. So this one's a lowercase y because usually this one's going to be a vector, not a matrix because it's not multidimensional. It's only our target only has one column, right, which is just our salary, so it makes sense to only represent that as a vector, while the features can be a matrix because you could potentially have multiple columns, okay? So that's why it's lowercase, because it's a vector. So y is equal to dataset.iloc. Now we want to tell it again what rows and what columns we want to grab. So we still want to grab all rows, so we'll do colon again, but now we only want the last column, so an easy way to specify that is just -1. We don't even need the range with the colon. We can just say just -1, which will automatically target the last column. So now it's going to print out y, and we got an error because we forgot to rerun this one. So boom, and then boom, and there we go. So now we have y, which is our salary. All right, so now we've separated our data into two different distinct, little mini data sets, right, for our features and then for our target variable. But if you hover over these variables, these are still data frames. It shows you right there, data frame. And that's fine, but usually when you're doing machine learning, these libraries that we're going to be using is going to want it to be in a NumPy array. So NumPy is just another popular library that is common for machine learning that I told you about before. So we just want to do dot values on the end of these data frames here. And all that will do is instead of returning a data frame from this, it'll convert the data frame to a NumPy array. So now if we go ahead and print these out again, let's see what it looks like. So here we go. Now we get a little bit of a different representation. It looks a lot like a multi-dimensional array for the first one, which kind of makes sense because I told you that one's going to be a matrix, and a matrix can be represented as a multi-dimensional array. But then the second one prints out just as a normal array because that's how you can represent a vector. So all we have done is import our data, visualize our data, and then we extracted it into a feature set and a target set, which is a matrix and a vector, and therefore now it's in a format that we can use to start doing machine learning. So before we actually feed it into the model and train the model though, we want to again split the data into a training set and a test set. Normally you do something like an 80-20 split, where 80% of the data is going to be used for training the machine learning model, and then 20% of the data is going to be used for evaluating the machine learning model. And again, the reason for doing this is because you don't want to test or evaluate the results of your model based on all the data that you just trained it on, because then you're not going to get a real picture of how the model performs on unseen data. The most popular machine learning library that you're going to be using is called scikit-learn. This is what we're going to use to create our model, but it also has a function that we can use to do the split, which is nice. So we can go ahead and do from sklearn.model_selection import train test split. So this train test split is a function that we can use to split our data however we want to. So let me just write it out and then I'll explain it after, okay? So I'm going to do x_train, x_test, y_train, y_test is equal to train test split x, y. Then we'll do a test size is equal to 0.2, and then we'll do a random state of 1. So what this is doing here is it's taking in our features and then also our target, and then we're giving it a test size of 0.2, which is telling it take that data and split it up 80-20. So 20% of this, 0.2, is going to be used for testing. So now instead of just having x and y, we're going to have x train, which is going to be 80% of that original x data that we have here. And then we have x test, which is going to be the other 20%. And then we have y train, which is going to be 80% of that original y vector that we had. and then we have y test, which is going to be the other 20% of that y vector that we had before, okay? And it's really that simple. We're just taking our x feature matrix, and we're also taking our y target vector, and we're splitting up 80-20. That's all it's doing. So now we have these 4 different variables here for that. The random state parameter that we have here is the seed for the random number generator, which just means that every time we run this function, it'll always give us the same split. That way we just have consistent results when we're testing this out. That's common practice. So now that we have this data, let's go ahead and try and get a look at what it looks like, what the shape of it is. So with that said, you can actually just do print, and you could do x train dot shape. Let's go ahead and run this and see what we get. So we get 24 and 1. So behind the scenes, this is a NumPy array that has the dimensions of 24 rows and then 1 column. That kind of checks out, right? Because we only have 1 feature, just like before. Let's go ahead and do the same thing for these other arrays that we have. So we'll do for tests, we'll do for y. All right, let's run it again. Now we get 24, 1, 6, 1, so that's the other 20% for the x. And then we have 24, comma, and then nothing. That's just how you know it's a vector, not a matrix, because this is a matrix with 2 dimensions. And then also you have another vector, 6, and then nothing. That's just the other 20%. So hopefully this is all, I really hope this is all making sense so far. I'm really trying to do this step by step so that you understand what's happening. If you have any questions, feel free to ask in the comment section below. But now that we have our data in a format that we need it in, which is a NumPy array, but also split up into an 80-20 split, so that we have a training set and a test set, we can now finally train a machine learning model. And it's going to blow your mind how simple this is. It's really easy. So we're going to go to import sklearn from the scikit-learn package, but it's called sklearn, linear underscore model, import linear regression. So all we're doing here is importing the linear regression class or linear regression model from sklearn or scikit-learn. First step is to create the model. Create the model. So we're going to make a new variable model is equal to linear regression. Just like that. That's literally it. But now we can go ahead and train the model using the training set. So all you got to do for that is do model.fit, and then into that you're going to pass in the features, so x underscore train, and then the actual answers for those, which is y underscore train, so the salaries. So we're going to do x underscore train, and then y underscore train. So behind the scenes, what this is doing is training your machine learning model for you, which like we talked about before, is literally just finding the slope and the y-intercept. Or in other words, you're finding the thetas or the model parameters that we talked about for that more advanced formula. But the fact that we can literally just call a single method here on this linear regression class is kind of insane. It's kind of insane because the actual implementation of these machine learning models is pretty complex. So obviously we don't know if it's, really working at all yet until we test it out. So one thing we could do right away is get the models prediction on the test set. So we could do y underscore prediction, which would be our y hat, and then we could do model.predict, and then you're going to pass in the test set. So you're not passing in the actual answers. So if we go back up, we have x train, x test, we have y train, and y test. So we're passing in the x test set, right? But we're not giving it the y test, which is the actual answers, the actual values. We're letting it generate predictions, and then we can compare these predictions to the actual values to see how different they are and evaluate the performance of the model. So when we call model.predict, it's literally using the model that it just trained. It has the coefficients stored within itself, and it's going to try predicting these values here, okay? So let's go ahead and print it out to see what we get. So y underscore pred, that stands for predictions, not something else. So let's go to run this now. And we get this. So this looks a lot like a vector, right? So we got 75,000, 91,000. These numbers don't really mean a lot to us. So let's compare these side by side with the actual values. So we can do print y test, right? Because the y of the test set is the actual values for the x of the test set that we passed in when doing the predictions, right? So let's go and run it again. And here we go. So we get 75, 83. It's a little, not too close. We get 91,000, 98,000, 62, 63, 67, 61, 89, 91. So they're a little off, but this doesn't mean a lot to us. Don't take that for like the model's trash, right? We want to actually evaluate it using evaluation metrics to see how far off it is, but also it'd be helpful to visualize it. Let's start by visualizing how well our model does on our training set. It should obviously do really well because that's the thing that we trained it on. So it's not necessarily an indication of how well our model is in general. That's why we have a test set in the first place, but let's just see what it looks like because that's the original graph that we showed pretty much for the most part. So yeah, we're just going to use matplotlib, same as before. We're going to do a scatter plot. So this is just plotting all of the training data points onto the graph. Then we're going to do a plot line. The x will be our training x values, and then the y values will be our predictions that the model is going to be used based off of the x training data. That'll be the blue line, and then we just have the labels and title. So let's go ahead and run this and see what it looks like. All right, so here we go. We get our red data points. So these are the actual values that our dataset has for the training set. And then the blue line here represents our model's predictions. As you can see, this one's actually spot on. So if you have roughly 6 years of experience, that should be pretty damn accurate. But other than that one, the dots are a little spread out, but the plot line goes pretty much in the middle of all of these. So it's safe to say this is a pretty good line, because if you were given a graph that looks like this without the line and you were told to make a best fit line, this is how you would draw it. You would draw something very similar to this. Let's go ahead and plot the same thing except for our test data set. So we're going to make a new code block here, and we're going to change some of these. So instead of x train and x or y train, we're going to do x test and y test, so we can see the actual data points, and then we're going to see how the model predicts it. So we're going to predict based on the x testing data. That should be good. So let's go and run it now. So right away you'll notice that it looks a little different, and this is because we don't have a lot of data. Our test set is only 20% of our total data set, but our total data set only has about 30 rows in the first place. It has a lot less data points than the training set. But as you can see before, we have our actual values being plotted, the red dots, but then we have our model prediction line, which is roughly in the same direction. It's a linear line that runs roughly in the same area as the actual prediction value. So, I mean, this is pretty good. Obviously, it's kind of hard to tell because it's so small, but roughly it's not very far off. So that's a good sign. Now, obviously, you don't want to base your model's, performance just on graphs and just looking at it. You also want to have some actual metrics that you can look at. Scikit also has some nice tools for that. So you can do sklearn.metrics import mean squared error and R2 score. So the mean squared error and the R2 score are metrics that I'm going to cover a lot more in the future. I'm not going to explain them really in this episode. I just want to show you guys how you can use these to evaluate your model. So we're going to print the mean squared error first. So print mean squared error, and then we can do mean squared error. And before I pass in these parameters, I want to explain to you what is the error. So generally speaking, what is error? Error is the difference between the actual values and the predicted values. In other words, it's the difference between the y test and the y prediction. So let's take those things and then pass them into this function here. So y test and then y predictions. And let's see what this gives us. So let's run it now. And we get the mean squared error, which is a really high number, which is actually not good. You want this to be as low as possible. Let's also try out the R2 score. So print R2 score, R2 score, Y test, Y prediction. Let's run it now. And we get 0.76. This one you want to be as close to 1 as possible, so this one doesn't look as bad. But so like I said, I'm not going to really dive deep into these values here, but the mean squared error with such a high value is not a good sign for the performance of our model. But the R2 score is kind of promising. That's pretty close to 1. But we also have to take into account that we have a really small data set with only 30 data points, right? That's not a lot. And if we just look at these plots that we have here, it does seem to roughly be able to capture the best fit line for the data that we have. So we should be able to, generally speaking, predict someone's salary based on their years of experience. In the future, we're going to try working with much larger data sets, and you always want more data. The more data you have, generally speaking, the better results you're going to get. Of course, if you're doing everything else correctly. In this case, we only have 30 rows of data, so I think it's okay that we're not getting exactly like really good results here. So I think for the amount of data that we have, I think this is perfectly fine. Anyway, so now that we have our model, this means that we also have our slope and our y-intercept, right? So we can actually print those out if we want to. If we want to extract those, we can do that. So we can get the slope, and that would be the model dot coefficient, and we can print the intercept model dot intercept like that. Let's run it. There we go. So we get 9332 and then 25609. So in essence, this is our model. We can take this slope and we can take this intercept and create a simple line out of it using y is equal to mx plus b. And with that, we can have a best fit line for this data that we have here in our table. Here's another little example that I want to show you. So if you want to predict the salary of someone with 10 years of experience, let's say that you have someone at another company and you want to see how much salary they could be making potentially. You could get their years of experience and then you could pass it into the model by doing this. So you get their years of experience, you pass it into the model, the predict method, and then what it's going to do is run the predictions based on the internal coefficients that we've calculated in the intercept, and then it should output a prediction, which is the salary. So yeah, let's run it. There we go. So we get the salary of someone with 10 years of experience is roughly 118,000. And if we take a look at our data again, that roughly lines up, So when we get to the 10 years of experience range, it's around that area. So we get 112,000, we get 122,000. That's pretty damn good. All right, so that's pretty much all I want to show you guys. I really hope you learned a lot from this episode. If there's anything that you're confused on, please let me know. This is my first time making a in-depth machine learning video. After watching this video, you should have an understanding of what a simple linear regression model is. At the highest level, it's just a line formula that you're calculating. But besides that, you should also know how to import a data set, describe it, take a look at, what its attributes are. You should be able to make a basic plot so you can visualize your data. You should be able to extract your data into a feature set and a target set, so the X matrix and the Y vector. And then you should be able to split your data into a training set and a test set. So you can train the model, you can test the model, get the predictions of the model, and then you could evaluate the model to see how far away the predictions are from the actual values. I don't know about you, but I think that's pretty damn cool. I love how easy it is to do all this, especially because we have stuff like Google Colab where you can just run all of this, without having to worry about installing packages or installing Python. It makes it really easy. So make sure you check the description below for all the code for this episode. I'll have a pre-made notebook for you to check out, so you can just run it code block by code block if you want to, or you can clone it, whatever you want to do with it. Just check the description below for all of that. And yeah, stay tuned for next episode where I teach you guys more stuff about machine learning. In the next episodes, you can expect some more advanced videos on how to pre-process your data, how to do multiple linear regression so you have multiple features, more complex data sets, and we're going to jump into all kinds of things like classification. Eventually, we'll jump into neural networks with deep learning. Just a lot of stuff to learn about. So hopefully you're excited and stay tuned for more. So that's it for this video, everybody. I really hope you learned something new. If you liked the video, please hit the like button, and if you want to see more, hit that subscribe button. Make sure to also check the description below for important links to code and other resources, but also really important, join our Discord. We have a big community of over 5,000 programmers, and it's a place where you can find new friends or get help on any code that you're stuck on. If you want to support what I do on this channel, please consider hitting the join button below, and this will allow you to support my channel for as low as $1 a month, but there are different tiers to choose from if you want to. For anyone that becomes a member on my channel, you get a special rank on my Discord server, early access to new videos, and you can just see yourself on the screen right now. So if that sounds cool to you, feel free to join. If you don't want to, that's fine. If you can't, that's okay too. I really just appreciate you watching the video anyway. Thank you so much. And that's it. Peace.